Hello, my name is Max and I just finished building my Mendel 90. I still believe it's an awesome machine, and one of the reasons I believe it's awesome you can see right here. So I have to shift one of my Z-axes a little bit to the left because my smooth rods for the X-axis were too long, and all I have to do is to drill 4 holes and that's it. Try doing that with a different machine. Apart from that, it's still not really working, and that's down to electrical problems. One of the downsides of ribbon cables is that it's really easy to lose track which of the wires you connected where, and it's pretty easy to lose count. So I believe that's a problem and that I have a short somewhere, but you know, I will figure it out. It shouldn't be that much of a problem. Another little problem is that I have a standard weight extruder, but the Mendel 90 is actually using a custom weight extruder. Basically, the Mendel 90's weight extruder is mirrored along the XZ plane. So it would look just like this one, but the motor would be at the front. Like the motor would be rotated 180 degrees. And that's important because you are supposed to have access to the back side of the motor so that you can attach a connector to it. Basically, the extruder is built in a way, or the X carriage is built in a way, rather, that you can easily swap out the extruder. And you just have a connector, and the ribbon cable is connected via that connector, so you can just unplug it, really quickly change your extruder, and then plug the ribbon cable right back in, and then you're good to go. So, in theory, that's awesome. Right, but, well, I don't have that special extruder, so the motor is actually colliding with the gantry at the left side. And I also had to trick a little bit with the connector, but apart from that, it's okay. Just have to make the gantry a little bit wider, the opening, but that shouldn't be too much of a problem. I also had a little problem attaching the belt there, like the bearing there to the left, but, you know, I wouldn't build a rab if I wouldn't be able to improvise. Improvisation, I believe, is a really important part of building a rep machine. X-carriage also has a built-in tensioning system, like all modern X-carriages do, and it works really well. There's even a little plastic part that pushes the belt outwards, so you do not have a screw pushing at the belt, which might damage the belt. Instead, you have a plastic part, so you have a nice even pressure on the belt, which you know, is nice. So yeah, here you can see me connecting the connector, which isn't supposed to work this way. And now we start actually soldering all the stuff together. Again, one of those wires of the ribbon cable is rated to 1.2 amps, so I believe those are 26 wires, so I have 24 wires for my heated bed and 2 wires for the thermistor. That means that I have 12 times 1.2, that's 14.4 amps that I can put through there. And that's actually pretty close to what my power supply can put out, so it's actually safe to use a ribbon cable to power your heated bed, so that's pretty awesome. But do it, you know, do it right. Take some time and make it right, because it is a lot of current and you can easily, you know, destroy it. If you just destroy a couple of wires, then you might burn your whole cable and it would suck. So do it right, use sleeving, right? Make sure you don't have a short. 12 amps is actually a lot, so you can die. Your machine can burn down. Do it right. Also, the Mendel 90 features this insulation at the bottom of the heated bed. Just by the way the heated bed is built, it heats up the top and bottom side the same. So by insulating the bottom side, the top side should heat up faster. And this is done by basically cardboard and some aluminum foil, and that's basically it. And it should work great. The little slit you see there is so that the ribbon cable can... As a real ribbon cable has some... Oh, what? Am I growing bald or what? No way. Damn. Anyway. So a little slit is for the ribbon cable to fit in there. Yeah, what was I saying? Yeah, I'm actually soldering to NASA specs here. There's a really simple way. The NASA actually has released the NASA soldering specs. And it's really easy to solder to NASA specs. And you should do it, because it's cool. End stops, yeah, the Mendel 90 is actually using micro switches, no more opto end stops. I never really understood why people used opto end stops in the first place. The explanation I heard why everybody was using opto end stops is because apparently micro switches could break too soon, but that's just ridiculous, to be honest, because in your mouse you have 2 micro switches, at least 2. Most likely 3, right? Left, right, and middle mouse button. And they don't break. Like, have you ever seen a micro switch in your mouse break? You use them literally millions of times and they don't break. They can be used, I believe, 1.5 or even 2 million times before they break down. So if you're actually able to make 2 million prints with your printer, then changing the micro switches is the least of your concern. So I believe micro switches are way better than opto end stops. They are cheaper, they are easier to build, they are easier to attach. You do not need to power them and stuff like that. It's just overall better in my opinion. Also, this machine homes upwards. It does not have the end stop at the lower end of the Z-axis. It has the end stop at the upper end of the Z-axis. That's also really cool because you want your end stop at the Z-axis. So if you home down with the Z-axis, you want to stop like 0.3 millimeter before you hit your print bed for the best results, right? Or 0.2 millimeters. And positioning an end stop by hand so precise and so accurate that you actually get the 0.2 to 0.3 millimeter. That's almost impossible. And there are tons of threads in the RepRap forum asking just that. How do I attach my that end stop in a way that I can precisely position it so that the extruder nozzle actually stops 0.3 to 0.2 millimeters over the print bed? And there isn't really a good answer. Like there are a lot of people saying, oh yeah, you have to attach a screw and stuff like that. But isn't it just easier to home upwards and then change a number in your firmware? Like you home upwards and then you tell your firmware, look firmware, I just homed upwards. The real Z0 position is such and such many millimeters below this position. Wouldn't that be really easy? You could even probably do it in G-code, right? I don't foresee it to be too big of a deal. All right, now soldering the connector. Actually, that's a print connector, but you can really easily solder stuff to a print connector, but you need a needle. So basically what you do is you wrap a wire around a needle, and then you strip the wire from the needle, and then you already have this coil that you can position around one of those pins. It works really, really well, I have to say. So it's a nice little awesome trick. If there is, if people want to see it, I can make a short tutorial about how to do it. So what I'm trying to do here is that I'm trying to use each other pin, because here's the thing. Every charged particle that moves has a magnetic field. So if you look in the direction of the movement of the particle, the electric field rotates in clockwise direction around the particle. It's also called right-hand rule. So what happens is that this magnetic field can actually be a problem for your sensors, because what can happen is that you induct electricity in the wires of your thermistor or of your end stops, and then you get a false signal. So your end stops believe they are triggered when actually they weren't, or your thermistor could give you wrong values. So what I tried to do here, what ended up failing because I didn't really look up the pin assignment of the connector. What I wanted to do is I wanted every other wire to be wired in one direction, so that I had one wire where the electricity, so I had one wire where I had plus, and right next to it would be a wire where I had minus, because this way I would get one electron traveling forward with an electromagnetic field in a clockwise direction, and on the wire right next to it I would have an electron traveling in the other direction with an electromagnetic field rotating counterclockwise. And what that would do is that both of those electromagnetic fields would actually annihilate each other. So in the end, you wouldn't have any electromagnetic field left anymore. That's actually what's done basically everywhere you have to transmit signals. You always do this. You always have one wire plus, next wire minus right next to each other, so that both of those electromagnetic fields annihilate each other, so you don't have cross speak. You don't have wires communicating with the wires next to it. Unfortunately, because I didn't look up the pin allocation, as it turns out, if you use every other pin, that does not mean that you use every other wire in the ribbon cable. Anyway, I didn't film me actually wiring it all, because that's just me using a multimeter and a lot of time to figure out which wire is which. My name is Mad Max. Thanks for watching this episode, and tune in next time.